Hello Math 131, Exam 3, question number 1. Simplify the complex rational expression using either method 1 or method 2. Well, I used both of them just to show you how they were done, but you only need to do one. Method 1, I'm going to multiply this complex fraction. It's complex because it has little fractions embedded in the big one, by multiplying the top and the bottom by the LCD of the baby fractions. And the LCD of the little fractions is a squared. So I multiply both terms on the top by a squared and both terms on the bottom by a squared. And when I simplify, no more little fractions. Now I factor and cancel for my final answer a over parenthesis 5 minus 9a. Method 2 would be to get a common denominator on the top and a common denominator on the bottom, which I did here and here, and then take the top, divide it by the bottom, and change that to multiplication by the reciprocal of the other one. So we turn the second one upside down, top times top over bottom times bottom, factor and cancel, and we get the same answer as method 1. Number 2, reduce a rational expression to lowest terms. In other words, simplify. Okay, so there's too many variables here, a's and b's, so I'm just going to think of it this way with just a's in it, and I'm going to factor it that way. And at the end, I'll plug those b's back in. So 5a squared plus 8. Oh, wait, the first thing I did was here. I factored out the greatest common factor on the top and bottom. It was 3, and I canceled it. Now I'm going to factor the bottom, but I'm going to ignore the b, and I factor it as 5a plus 3 times 5a plus 1, and then I plug the b back in. And here's my factorization down here. And I'm able to cancel a common factor of a plus b. That leaves a 1 on the top, and then the parenthesis on the bottom, and the final answer is 1 over 5a plus 3b. And that takes us to our next question. Now we're going to simplify rational expression number 3. Factor and cancel. Factor the top, factor the bottom. We see we have a common factor of parenthesis m plus 4, so our final answer is m plus 2 over m plus 3. And of course you cannot simplify by canceling the m's, because you're only allowed to cancel factors, things that are multiplying. Those m's are not multiplying anything, they're adding. Number 4, perform the indicated operations. Always simplify your answer, of course. Well, we have a big fraction on the top divided by a big fraction on the bottom. So we use the fact that that is the same as the big fraction on the top multiplied by the upside down of the bottom. So you see I turned the second fraction upside down. Now I factor each of the fractions and I cancel as much as I can, and I get y plus 7 over 2y plus 1. On the side I just showed you all of the side work that I did. Let's move on to the next question. Now we are on question number 5, and be careful because here they're not asking us to multiply or divide, they're asking us to add. Okay, so I gave you a hint, simplify the numerator, that's the top. And well, your simplified numerator in your final answer cannot be factored, so don't waste your time trying to factor the top at the very end. Okay, so let's go to step 1. First, we're going to factor each of our fractions. We're able to factor the bottom. Now, we cannot add unless we get a common denominator. So examining each of the two denominators, we determine the common denominator needs to be c plus 8 times c plus 2 times c minus 3. Okay, to get the first fraction to have that denominator, we must multiply by c minus 3 over c minus 3 across the top and the back. To get the second fraction to have the common denominator, we must multiply the top and the bottom by c plus 2. Now that means we can distribute the multiplication on the top of each of these fractions. Oops, trying to clear that up a little bit. And we get c squared plus c minus 12 for the top of the first one, plus 3c squared plus 4c minus 4. Let's go ahead and simplify the top. It's all over the single common denominator. Simplifying the top, we get 4c squared plus 5c minus 16 over the bottom. So this is what the hint was about. Don't waste your time trying to factor the top and then cancel, because I told you in the hint you cannot factor the top. It's prime, so don't waste your time trying to do it. You're finished. Question number 6, we're going to take two fractions, and instead of adding them like we did in number 5, now we're going to multiply them. So step 1, we're going to factor the first fraction on the top and bottom, factor the second fraction on the top and bottom. Now don't forget, because we're multiplying, we do not need to get a common denominator. We can just multiply across the top, multiply across the bottom, cancel any common factors for our final answer. X parenthesis x plus 3 over parenthesis x minus 5. And then we have number 7. Okay, this is a subtraction between two fractions, and there's a big hint that will really help and save you time. It says to simplify before you do anything else. So I look at the first fraction, I factor out a common factor of 7 and p, it leaves parenthesis p minus q. On the bottom, I factor the difference between two squares and check out what happens. We have a common factor to cancel. Minus, we cannot factor the top of the second fraction, just leave it as 7p minus 11q. The same thing with the bottom, leave it as p minus plus q. The good news is now, look, each of our fractions have a common bottom, so we can do the subtraction across the top, but be careful, that minus sign has to be distributed across the second top of the parenthesis. So we get 7p minus parenthesis 7p minus 11q over the common denominator p plus q. So when we distribute the negative sign, the 7p's cancel, and our final answer will be positive 11q over p plus q on the bottom. Next we have number 8. The voltage across a resistor is jointly proportional to the resistance. Okay, right away that tells us V equals K times R times I. It's jointly proportional. We're told that V is voltage, R is resistance, I is current, K is the proportionality constant. So we have V equals K times R times I. Okay, then it tells us if the voltage across a resistor is 72 volts for a resistor whose resistance is 8 ohms, and when the current flowing through the resistor is 9 amps, find the voltage across a resistor whose resistance is 4 ohms when the current flowing across the resistor is 7 amps. What the heck? Here's what they told us. They told us joint proportionality. So they said V equals K times R times I, with V is equal to 72 when R is equal to 8 and I is equal to 9. Those are our initial conditions. Then it says find the V, the voltage, when R is equal to 4 and I is equal to 7. See, when you write it that way, it's not so bad. Okay, step 1. Use the V equals, the initial conditions, V equals 72 when R equals 8 and I equals 9 to find K. So start with the formula you're given, plug in the values, and solve for the only remaining variable K. It's 1. Now take this equation and what's the word for it? You're going to refine it by letting K be 1. So you're replacing the K with 1. Now you're going to use this form of the formula with the other conditions. R equals 4, I equals 7. You're going to find V. Plug those values in. You get V equals 28. Number 9, determine the domain of the rational function. Answer in set notation. So it's a rational function. You set the bottom equal to 0 and you solve for x. You get 2 answers, but you're going to throw away these values. See, these are the values that make the bottom 0. So your answer will be everything but those nasty values. So the answer for the domain is curly set bracket, all real numbers x, such that x cannot be -7/3, x cannot be 1.